Let's start with creating a new project. Click New in the menu, and click AUTOSAR Project. Enter the project name. After clicking Finish, we can see that a new project is created. For the next step, we will create a new ARXML file. Right-click the project, select New, then select AUTOSAR File. In this example, we will cancel auto-generating AR package. When creating an ARXML and AR package in the same time, you can activate to auto-generate the AR package and change its name in practice. After clicking Finish, you can see the ARXML is created. Next, I will show you how to create system element through System Designer. Right-click the project, select AUTOSAR System Designer. We can find System Designer on the right side of the tool. To create system element, we need to right-click the system in Config tree, then click Add System. Then we will see a dialog for selecting AR package. I create one with the name of system. Right-click the ARXML file, then click Add AR package. Here we enter System for the name, then click OK. We can see System AR package is created. Click the AR package, click OK, so we can find that element is created under the system. You can find details in the page when clicking it. We keep the name unchanged. In the category, we choose Machine Designer Extract. In System Version, we enter 1.0.0.011 for instance. Save the file, and we can find the ARXML file is updated. The next part is adding composition in system. We will design a simple sample of communication between proxy and skeleton. Regarding the composition, we will put PAA and RAA under the machine. We can get to the designing page for composition by clicking System Element, VFB, System in Order. Right-click the system, then select AR Package. After selecting the System AR Package, we can find that System Composition is created. Next, we will add a new composition of machine and system. Right-click the system composition, then click Add Composition Software Component Type. We change the name of composition to machine. Next, I will add PA8 and RA8 compositions under machine. Right-click Machine Composition, then selected Composition Software Component Type. I will name the composition as PAA, and I create RA8 composition in the same process. Change the composition to RAA. So far, the whole composition designing is finished. In the next part, we will create mode declaration. 3 function groups, which are machine state, process state, and drive state, will be created. Machine state and process state can be created automatically. Right-click in the table, select Generate Machine State. This is the generated machine state. We can auto-create a new process state through the same process. So, this is the process state which is just generated. Next, we will create drive state. Right-click in the table, click Add Mode Declaration Group. Here we change Mode Declaration Group into Drive State. We will add for modes, which are high speed, low speed, off, parking. Set the initial mode as off. Next, we will create certificates. Click in order of Secure Communication, Crypto Service, then Certificates. Right-click in the table, click Add Crypto Service Certificate. For the AR package, we choose System again. I changed the name of certificate to My Certificates. For algorithm, I choose RSA, and for format, I select X509. For maximum length, I am going to put a random value, like 512 for example. So the certificate designing is finished. And next, I will show designing SD server config and SD client config. I will start with SD server config. We can find it under service communication. We can create SD timing and SD event group timing in SD server config. Click SD timing. In the right table, click Add some IP SD server service instance config. Here, I leave the name unchanged. For time to life, enter OX6F and set offer cycle delay to 0.1. For both request response delay mean and request response delay max, enter 0.0. Open initial offer behavior. For both initial delay min value and initial delay max value, I enter 0.1. And for initial repetition base delay, I enter 0.1, and for initial repetition max, I enter 3. Creating SD event group timing will be the next part. Right-click in the table of timing configurations, click Add some IPSD server, event group, timing config. For request response delay mean, I set the value as 0.0 and same for max value. For next, I will design SD client config. Select SD client config to configure SD timing and SD event group timing, which are under SD server config. Right-click in the table of SD timing, click Add some IPSD client service instance config, just like what we did for configuring server. Set the value of time to live as 0x6f and extend the initial find behavior to enter different time value. Enter 0.1 for both initial delay min value and initial delay max value. The values for initial repetition-based delay is 0.1 and 3 for initial repetition max. SD event group timing is the next part to set. In the table, click Add some IPSD client event group timing config. Leave the name unchanged. Set the time to live to 0x6f. I enter 0.04, both request response delay mean and request response delay max. Next one is machine design. Select Node in Topology to get to Machine. Right-click the machine, click Add Machine Design. For access control, I select Modeled. In configuration part, we need to configure Ethernet, user-defined, or service discovery config first. But we have not created endpoint, so we will come back here after creating endpoint. Here I will create Network Endpoint Ethernet Cluster. Get to Ethernet. Right-click Cluster and select Add Ethernet Cluster. So after this, an Ethernet cluster is created. For protocol name, I enter Ethernet. I put IEEE 802.3 for protocol version. Next, I'm going to create network endpoint of physical channel. Right-click and select Add Physical Channel. We name it as Network Endpoint. Right-click Network Endpoint. Selected Network Endpoint. Here I additionally create two network endpoint. Add network endpoint address by selecting Add IPv4 configuration. IP address is 192.168.0.5. The source is fixed. For default gateway, enter 192.168.0.1. And for network mask, it is 255.255.255.0. We put 0 in TTL. We can configure a lot of things in DNS. Here I will add one for instance. DNS will be 192.168.0.1, which is same as gateway. So far, I finished setting one network endpoint. I will configure loopback. Right-click Network Endpoint, select Add IPv for configuration. IP address is 127.0.0.1, and for source, I select Fixed. I put 255.0.0.1 for network mask, and 0 for TTL. Then loopback setting is finished. For the last part, I will add SD multicast. Right-click and select Add IPv for configuration. IP address is 224.0.0.1, and I select Fix for source. After entering 0 for TTL, 3 networks are created. I will apply the created network endpoint. Go back to Machine Designer, get to Communication Connector Ethernet, add Communication Connector. To add endpoint and to loopbacks, I need to add the communication connectors. I change the first one's name to endpoint, select wired in category, and connect unicast network endpoint to it. Change the second one to localhost, which is also wired in category. Connect unicast network endpoint to loopback. I will configure Service Discovery config 2. Right-click and select Add Service Discover config. Select SD Multicast for multicast SD IP address and enter 30 for 90 for SD port number. Finally, I will apply Machine Design and Ethernet cluster to machine element. Go back to machine. We can find 5x elements. Add machine design, then click OK. Add machine as reference in Ethernet cluster, then click OK. And lastly, we can see machine design and Ethernet cluster are added here. I will show how to create data type through Datatype Designer of AUTOSAR IO. Right-click the project, open AUTOSAR Datatype Designer. In Adaptive Platform, we can create CPP implementation data type and data type implementation. Here, I will create 11 kinds of basic data types and type references. Right-click and select Add STD-CPP implementation data type. I will add and select the AR package of data type. Enter Boolean data type and select Value in category. Go back to AR package, select data type, and create and assign integer 8-bit in the same way. Additionally, set type emitter to CSTD integer. The third one is unsigned integer 16-bit, and the value is the same to the previous one. The fourth one is unsigned integer 32-bit, and its setting is the same as well. Again, same for unsigned integer 64-bit. Next one is signed integer 8-bit with same value. Create signed integer 16-bit in the same order. Create and configure signed integer 32-bit and 64-bit. Create float and same setting for category. Create double and same setting for category. So far, I finished creating 11 kinds of basic data types. Please pay attention to bool, float and double. We don't need to set type emitter for them. Next, I will add to type references. Right-click and select Add STDCPP Implementation Data Type. Then select Datatype AR Package. Change its name into Input Data and select Type Reference and Category. For this type reference, I set the referencing data as unsigned integer, 8-bit. And I add another one here. Change the name as output data, and same setting for the category. The referencing data is unsigned integer, 8-bit as well. In case of type preference, we need to configure namespace. So I enter user data. I will create service interface through Service Designer. Right-click the project and open Service Designer. To add service interface, click Port Interface in Config Tree. Right-click Service Interface, then click Add Service Interface. I create an AR package named Service. Select the created AR package. Service interface is created. Change the name into my service interface. For namespace, I enter user service for example. I enter 1 in majored version and 0 in minored version. Next, I will create event in service interface. Right-click in the table to create an event. Change its name to my event and select the output data from Datatype. Next is creating field. Here, I right-click to create two fields. I create my field 1 and my field 2. For my field 1, data type is input data. Getter is true, setter is false, notifier is true. For my field 2, data type is same to the previous one, but the other values are opposite. Method will be the next part. I will create methods. I change the first one's name to RR method. Click false to select request with response. And I will add arguments. The name is input. The direction is in. The type refers to input data. And I add another argument for response. The name is output. The direction is out. The type refers to output data. Then I add the second method. Change the name to FF method, then click True, and select Fire and Forget. It also needs to add arguments. The name is input, the direction is in, and the type refers to input data. Since Fire and Forget doesn't have response, so only input can be added here. Next, I will create service deployment. Get to some IP in config tree, then select service deployment. Right-click in the table to add some IP service interface deployment. Select Service Air Package. I will make reference with the service interface I just created. I put random number for service ID, which is not duplicated. Major version is 1, minor version is 0. For the next part, I will add event deployment. Refer my event, which I created in service interface, and I enter random number for event ID. For protocol, I select UDP and some IP for serializer. Next, I will add method deployment. I have created two methods, so I will apply them here. The first one will be named as FF method deployment, which refers to FF method. The method ID is random number and select UDP for protocol. The second one is our R method deployment, which is referring to our method. The method ID is random number and UDP for protocol as well. Next, I will add field deployment. Here I create the first field deployment and select my field 1 for field. Here I am getter and notifier. Enter different method ID respectively, and select UDP for protocol. Same as method ID, I enter random value for notifier. For protocol, I select UDP and some IP for serializer. I create the second field deployment, select my field 2 for field. Add setter for my field 2, enter random value which is not duplicated, and select UDP for protocol. For next, I will create event group. I will create 2 event group, which contain notifier of event and method respectively. First, create event group 1, enter 1 to avoid repeated value, and add event as reference. Next, create event group 2, enter 2 for group ID, and add event as reference. And add notifier. So I finished creating service deployment. Next part is creating service instance. Get to service instance under some IP. Select and add skeleton first. Select service air package. Add the newly created some IP service as reference for service interface deployment, and put random value for ID which is not duplicated. For SD service config, I need to enter the value that is created in system design. I will create provided event group for next. Since I have 2 event groups, so I will create a for reference. Add two method response props as well, adding method respectively. For next, I will add service instance of proxy. Select the service AR package. Make it refer to some IP service, and set the ID as any since it is proxy. For SD client config, load the config created in System Designer. Next, I will add event group as well. Add event group and select timing config created in System Designer. Create a method response props and add method. Next, I will start mapping the created service instance to machine. Get to machine mapping, right-click to add some IP service instance to machine mapping, and select Service AR package. For communication connector, I have the endpoint, which is designed in System Designer, then enter random port. Select Proxy for Service Instance here. Change the name to Proxy to Machine Mapping. So this is the designing process of mapping for some IP proxy. And same process for skeleton. Designate an endpoint, then enter a random port. This time select skeleton, then mapping is completed. For the last part, I will show how to automatically generate service deployment and service instance. Right-click the created interface. Select Generate some IP Service Interface Deployment. We can see that service deployment is automatically generated. It automatically defines essential ID value, so if I right-click deployment, I can auto-generate the different instances. In this video, I will show you Adaptive Machine Designer of AUTOSAR IO. I will design a machine with it. Right-click the project, select Adaptive Machine Designer to start designing machine. Here, I will add machine. Right-click Machine and Machine Manifest, select Add Machine. I create a new AR package called Machine. Machine design refers to the machine, which is created in System Designer. In Trusted Platform Executable Launch Behavior, select No Trusted Platform Support. In Function Group, I am Machine State and Drive State, which are also created in System Designer. Right-click and select Add Function Group. Select Machine State for type and change its name to Machine State. Next, create Drive State in the same way. In the type, select Drive State and change its name to Drive State as well. For the next step, I will add processor. Right-click in the Processor tab and select Add Processor. I will add several cores in processor. Enter 04 core ID. Next part is environment variables. We can put random names for environment variables key. Here I enter BNV key and BNV value. I need to set environment variables according to different environments. I will add OS module instantiation and assume Linux as Object OS. Right-click the resource group, select Add Resource Group. Set the CPU use rate to 80% for safety, and the memory can be set by byte unit. Here, I will set the memory usage to 1 GB. so I finished designing the machine for adaptive AUTOSAR. In this video, I will show Adaptive Application Designer of AUTOSAR IO. Right-click the project, open Adaptive Application Designer. I will configure applications of skeleton and proxy, so I will create executable for the applications. Right-click Executable, select Add Executable. I create a new AR package called Application. We can see that one executable is created. I will start from executable of skeleton. Change the name to EXEPAA. I choose application level and category, reports execution state and reporting behavior. The version is 1.0.0.001. Next, I will configure root software component prototype. For application type, I select composition PAA, which is created in System Design. Then, I will create executable of proxy. Change the name to EXERAA. Select application level and category, and reports execution state and reporting behavior. The version is 1.0.0.001. I will configure root software component prototype for next. For application type, select composition RA8, which is created in System Design, and I will create software component for respective applications. Right-click and select Add Adaptive Application Software Component Type. Change the name to Skeleton. I will add port. IP port because it is skeleton. And I select proper service interface. Same way, I will add software component of proxy. Right-click and select Add Adaptive Application Software Component Type. Select Application AR Package. Change the name to proxy. I will add our port since it is proxy. And I have service interface. So I finished designing software component of skeleton and proxy. For next, I will connect software component type of composition from root software component, which are created in executable. So I need to go back to System Designer. Select Composition and put each software component type of composition in. Right-click PAA Composition, selected component, and add a skeleton I've created before. Same for RAA, I add proxy here. Save the current configuration and go back to Application Designer. We can see that proxy and skeleton are designated to respective root software component type. Since software component is finished, I will put each software component under root software composition. Root software component has two compositions of PAA and RAA, and I will put software component under them. For this process, we need to go back to System Designer. Click the system under VFB. We can see different composition tree, and we can find PA8 and RA8 under Machine. Right-click PAA, select Software Component Types. Add Skeleton Software Component because PAA is skeleton. And same process for RAA. Add proxy to RAA. Save the configuration and go back to Application Designer. We can find the software component under respective composition. For the last part, I will work on port mapping. Right-click in Adaptive Service, select Service Instance to port prototype mapping. Choose Application AR Package. Select Skeleton for Service Instance and PAA for root software component since it is skeleton. Select P-port for port prototype. and I add another one in the same way. Then I start mapping for proxy. Select RAA, then select proxy, and the process is done. So far, I designed skeleton and proxy through Adaptive Application Designer. In this video, I will show how to use Execution Designer. Right-click the project, open Adaptive Execution Designer. I will start from creating startup config. Right-click and add AR package called execution. Right-click in the table, change the name to Startup Config PAA. Select Other for Scheduling Policy and enter 0 in priority. For next, I will add Startup option. Set the name as Run. I will keep option argument blank since it's not necessary, and select short form for option kind. Next, I will create RAA start config. Same as PAA, select Other for Scheduling Policy, enter 0 in priority. I will add Startup option for PAA as well. Change name to Run, enter test and option argument, select long form for option kind. Next part is creating process. Right-click and select Execution AR package. Change its name to My Process PAA. Select PAA in executable and enter random value. Right-click in the table, create a process. Select Process State for type. And next, I will get to state-dependent startup config. For startup config, select PAA, then select the proper resource group. As we can see, config is automatically configured. For next, I will configure function group state. Select machine state in function group. Set the process to be operated when machine state start up. Then I will configure RAA in the same way. The designing process is the same to that of PAA until config part, but we need to additionally configure execution dependency. I have conditioned that when PAA starts running, process state should be in running state. I will also configure function group state. So I finished designing with Adaptive Execution Designer. In this video, I will create software cluster in Package Designer. Right-click the project, select Adaptive Package Designer. For next step, I will create software cluster of PAA and RAA on the basis of previously created application in root of software cluster. Right-click in root, select Add Software Cluster. Create the AR package named Software Cluster. Change the name to Software Cluster PAA. Enter the version as 1.0.0.001. Enter 79 for vendor ID. For signature, select My Certificates, which is created in Machine Designer. For next, I will add executable for packaging. Select PAA here. We can find executable is created. Next, I will add manifest execution. Also select PAA here. We can find PAA process is added as well. Next, I will add service instance. Select interface of skeleton. You can find service instance is created. For next, I will create vehicle package of proxy. Right-click the root, select Add Software Cluster. Change the name to Software Cluster RAA and version is 1.0.0.001. For vendor ID, I enter 79. For signature, I select my certificate, which I created in Machine Design. I will add executable in the same way. Select RAA here. You can see the executable is created. Next, I will add manifest execution. Select RAA as well. We can see that RAA process is created. Then I will create service instance. Select interface of some IP proxy. We can see that service instance is created. The next part will be creating software package. Select software package in config tree. Right-click in the table, then select Add Software Package. Change the name of software package to PAA. For software cluster, I select PAA signature as my certificate. Action type is install IS Delta package is false, and I enter 79 for ID. Regarding the package size, I enter 1024 for compressed size and 2048 for decompressed size. Actually, this part depends on the requirements. In practice, developers need to enter the actual package size. For the UCM version, I enter 1.0.0.0 for the minimum, and the same for the maximum. For activation action, I select Restart Application, and select False for pre-activation reboot, and post-verification reboot. So PAA software package is created. I will create RAA software package as well. Select software package in the config tree, right-click in the table, select Add Software Package. For AR package, I select Software Cluster. Change the name of software package to RAA. I select RAA for software cluster, my certificate for signature, and choose Install for action type, false for IS Delta package. The ID is 79. Here the same, 1024 for compressed size, and 2048 for decompressed size. The supporting UCM version is 1.0.0.0 for minimum and maximum as well. I select Restart Application for Activation Action, false for both pre-activation reboot and post-verification reboot. So, RAA software package is finished. So far, the example of data exchanged between two software packages of PAA and RAA through a service interface is created. We can find and check the example in the saved ARXML file.